Okay, 2.5 is now looking at scatter plot and line of best fit. I'm hoping most people have an idea of a scatter plot. We'll go over some of the basics. The key part here is going to be making predictions. How do you use a scatter plot to make predictions? We're going to look at two methods. One, just looking at the line of best fit and estimating where that point would be. The other one, it's still considered an estimate, but we're going to be using the equation of the line of best fit to make our predictions. First, I want to talk a little bit about scatter plots. Scatter plots shows relationship between two variables. Now, those two variables do have to follow some rules. Variables must be numerical and they must have a scale. And when I say scale, I should put in there a meaningful scale. You wouldn't be able to use jersey numbers for a baseball team to be the numerical value because player number 10 really isn't better or worse than player wearing number 8. So it has to have some kind of meaningful scale to it. It has to be numerical because you have to be able to put them on either the x-axis or the y-axis. Now, whatever the variables are, remember we have x, y, and what a scatter plot is, it's going to be points. For every ordered pair, each variable has either the x or y coordinate, we're going to have points. Okay, so that would be an example, and we would look and see what kind of relationship can we see between those variables looking at those 2 points. You're going to have to worry about positive, negative, and things like that when you're looking at these. How strong the relationship is, meaning how close the points together are when you're describing what's happening in the scatter plot. Now we are going to focus on correlation, which is a straight line relationship. Okay? We shouldn't have any curves or bends in our scatter plot. Now sometimes we can't help it, there will be curves and bends, but how hard they affect our predictions or how much they affect our predictions is going to depend on how big the curve actually is. Okay? Now, when you also talk about, I just said positive and negative, you're going to need to look at the direction and think of it as slope. Okay? When we had slope, we had a line going up was considered a positive relationship or a positive slope. Well, if you have a scatter plot and those points are going up, they're increasing. As x increases, y is increasing. Okay, that would be considered a positive correlation. So again, x increases, y is increasing. So x increases, y increases. Now if you have a negative correlation, the points are going down. Okay, also think about the line. The slope would be going down, that would be a negative slope. Okay? But now instead of x going up, y going up, now as x is getting bigger and bigger, the y value is decreasing. So as x increases, our y is decreasing. Okay, so kind of going the other way here. So you might have to come up with variables that fit one of these two either positive or negative situations. Okay, so you have to think about what kind of variable x increases is y also going to increase for a positive correlation. Same thing for the negative. As x is increasing, y is decreasing. Okay, so you have to think about what variables we're going to be looking at that could fit into those two situations. Okay. Now for the line of best fit, the line of best fit is a little tricky. You need to make sure you have a straight edge so you can draw it as straight as possible. We're looking at linear functions, so this is going to be a straight line relationship, and you want your point, you want your line of best fit to be going through the center of your points. It might not be hitting any of your points, but the cluster of points there, it should be going through that cluster. Okay. So if I was drawing a line of best fit here, there would be my line of best fit. You want to try to have the same number of points above and below the line. It'd be great if they all fit on the line. It's going to be very rare that that happens. Here we have one below, one above, and it ends up being at the upper end of the x variable there, but this would be a good line of best fit. Now even though graph B, it looks like it's still fairly straight, if I was to draw this line of best fit, Okay. We can see we have 2 points on the line, 1 above, 2 below. It's kind of not the best because below we have the one below very low, the other below very high, and the above right in the middle. That kind of shows you that there is kind of a bend for these graphs here. So you really have to be careful when you draw your line of best fit that it's even throughout, and you try to have points, even points above and below, and have them be the entire length of the line above and below, not below, above at the high and low points, and they're low at the 2 high points, and then above in the middle there. And graph C, you really couldn't be able to draw a line of best fit there. Okay, and we'll talk about when you have a horizontal line for your line of best fit, why it's good or bad looking at the situation. But you can see, for these two, you could pick, okay, that one's negative, this one here is going up. This one, you really couldn't trace a line here that's going to be positive or negative. So sometimes you're not going to be able to use a line of best fit. You're going to have to look at the graph and decide, are you able to draw that line? Okay. Now here's 2 examples. We have the graph on the left here. Points are very close together. And a lot of students want to say this is a strong relationship and has good correlation. I agree with the first part. It is a strong relationship because the points are close together. They are increasing, and then right about at this point here, when x hits 0, it starts to flatten out. That's something that's pretty easy to describe. To say it has a strong correlation, though, is not correct. A straight line is how straight it is shows you how strong the correlation is. If I was to draw this line of best fit, there's a couple different ways you could draw this here. Okay, if you want to just look at this part here, the line of best fit would go like that, and you have all these points that are far off, all at the top end here. So that's not a very good line of best fit. Another line of best fit you could draw, maybe playing into those points, tilting this a little bit so those points aren't as far away. That one might be a more accurate line of best fit, but if you look at the red line, you have all the points below very low, then they're all above in the middle, and then all below at the end. So again, not the best line of best fit. A good relationship, yes. Correlation, not so much. You can have a strong relationship without strong correlation. The other graph on here, the points are farther away. I would not say this is as strong a relationship, but if you draw a line of best fit, you can see it's even throughout. You have points above and below all throughout the line, and that's what you're looking for. This has a stronger correlation, and it'd be better to make predictions with that second graph compared to the first one. So just because the points aren't close together doesn't mean it has a weak correlation. This second graph has a stronger correlation compared to the first one. Okay. Now, using a scatter plot to make predictions. Erase some more here. Okay. You must stay within the scope of the variables, meaning you don't have to look at your data and you don't want to get too far away from those. When we start looking at examples, you'll see there's a range that you should be able to make predictions for. Okay? When you get far away from that range, your predictions become less valid. Things change, and you only really want to look at the data that you have, and your prediction should fit that data. Use the line of best fit, not your plots. Like I said, your line of best fit might not hit any points, okay, and that's fine. Once you draw that line of best fit, you're using the line and not those points. It'd be nice if you could get rid of the points and just look at the line. Might be a little less confusing, but remember, you're looking at the line and not just the plots. You use the plots to draw the line, but once you have it, you kind of got to ignore them for a little bit and use just the line. And watch your units when you're giving your final answer. These answers should go off of your X and Y variable units, so think about your variables when you're making your final answer. Okay, so here we're looking at ice cream sales versus temperature. Okay, we have the temperature down here in Celsius. We have the amount of money going on the y-axis. This is the amount sold in dollars. Okay, so let's draw our line of best fit for this one. And there's a decent line of best fit. Of course, you're not having a straight edge. You're going to draw yours a little nicer here. Now, types of questions you're going to answer, or you're going to have to answer. What interval of temperatures can you make predictions in and have them be accurate? This is what I'm talking about, the scope of the data. Our lowest data point for the temperatures we have at 12 degrees Celsius, and the highest one is probably about 25 degrees Celsius. So right there it's showing us that's about where we should be able to make predictions from. Could you go a little farther past? Yeah, you could probably do 26, maybe 27 degrees. Go down here to maybe 11, 10 degrees, but you don't want to go much farther. You wouldn't want to say 30 degrees Celsius and have that prediction be accurate. Stay within your data scope. Okay, so if I had to do this, it'd be about 12 degrees to about 25 degrees. About how much ice cream would you sell on a day that is 20 degrees Celsius? This is estimate, and you can kind of eyeball it, but the work I'm going to want to see is your lines going up and over. Those lines going up and over are going to show me that what you're looking at. So if I'm predicting 20 degrees Celsius, I'm going from that point 20 up and over. Okay, so that's showing, I know I'm looking at the 20 degrees. That's when it hits the line, and I'm going over it. Not a point. Okay, it's not going to hit any point. If it does hit a point, you go through it. We care about the red line that I drew. And drawing over is about $450. Okay, use the language of estimate or use the symbols. Okay, that's $450. Okay, or use between 400 and $500. Okay, make sure you put your dollar sign so you have those units. So estimate, we're using the language of estimation here when you're making your prediction. Do not say it is $450. Okay, this is an estimate, so about, around, just above, just below a value. There's the words that I would like you to use when you're answering these questions. Okay, so here's another example. CDs and cassette sales, we have 1988 to 1996. And if I had to draw my line of best fit for this one, again, be careful, take your time. And you might have to draw it once, look at it, make your first one nice and light. Okay, so I'm going to draw my line of best fit there. If you draw it, and once you pull your ruler away, sometimes you see it's not the best one to look at. Take it away and draw it again. Erase it, draw it again. So do your first one nice and light. Okay, so there's my line of best fit. The question is time about how many cassettes sold when 900 million CDs are sold. So really you have to think about, the reason I have this problem, thinking about the units. Okay, it's in millions. So showing the work for this one, yeah, 900 is just outside our last point. We're looking at 900 million CDs right here. So it's a little farther out, but that's about as far as I'd want to go. I wouldn't want to go much farther than that. If I'm going up and over, okay, make sure you watch your units on this one. Okay, think about what the scale's counting by. It's not counting by hundreds, 100 millions like it is on the x-axis. This would be 225 million cassettes. Okay, so I'm just below 225. So that's how actually I'm going to put it. Just under 225 million cassettes. Okay, so make sure you have those millions. There's a big difference between 225 cassettes and 225 million cassettes. So make sure you're putting in those units so that's part of your final answer. Now, you're going to really have to take a look at these when you're drawing line of best fits and think about how strong a relationship it is and take your time. For the graph with the temperature and ice cream, the graph with the CDs and the cassettes, everyone's line of best fits is going to be pretty accurate. I mean, those are pretty strong relationships, so everyone's going to be about the same line of best fit. Okay, we're looking over at this one over here, and I'm just looking at how it's a little more spread out. Everyone's line of best fit might be a little different. So your answers are going to be a little different. Don't look over at your partner or someone next to you and think they have a different answer, so I'm wrong or they're wrong. You both could be accurate, or you might both be correct, depending on what your line of best fit is. Okay, so that's making predictions using the line of best fit. The next part is on me writing the equation for the line of best fit.